Hey guys, this is Mr. Teen Tutor here, and this is part 2 of the rational functions. I hope you guys have watched part 1. If you haven't, go watch that now, but if you have watched part 1, this is part 2, and this is where we will finish the problem. So in this problem, or rather, I'm sorry, in this part, we are going to find a horizontal or oblique asymptote, if any, and we're going to determine if the graph intersects the horizontal or oblique asymptote, and then we're going to graph it quickly. Just make a good sketch of it. Okay, so in order to find the horizontal and oblique asymptotes, we need to use long division, and this is why. If you remember from my last video, a proper function is when the denominator of the rational function is greater than the degree of the numerator. That's a proper function. An improper function is when the degree of the numerator is greater than the degree of the denominator. That's when you use long division to find the horizontal oblique asymptotes. But when the degrees of the numerator and denominator are the same, you still have to use long division to find the horizontal or oblique asymptote. So we're going to use 3x plus 1 over x minus 2. We're going to use that simplified version. It'll make life a lot easier. Now I hope some of you have a good understanding of how to do long division, but if you don't, I'll go over it anyway. Just to review, this is called the dividend, this is called the divisor, and of course this is called the quotient. And there's a remainder. So when you do long division, you see how many times the first term, only the first term of the divisor, goes into the first term of the dividend. How many times? 3 times. And we're going to put the 3 above the 1 because the 3 has no variable and 1 has no variable, so it makes sense to put this above. And then I'm going to distribute this 3 to the x and the 2, so that's 3x minus 6. Now, here's a note for you guys. When you encounter a negative number as a result of this distribution, put it in parentheses. Because, after all, when you're doing this kind of step in normal division, you're subtracting at this stage. So this is 1 minus negative 6. Not 1 minus 6, 1 minus negative 6. This is 0, so this is 7. Now to continue on, you say to yourself, how many times does, again, the first term of the divisor go into this term? None. So we stop right there. So therefore, the answer is 3 plus 7 over x minus 2. However, we're going to discard the remainder. We're not going to worry about that right now. In order to find the horizontal oblique asymptotes, just don't worry about it. And you basically said y equal to whatever's left. So you said y equal to 3, which is a horizontal asymptote. So remember, an oblique asymptote is a slant, or like a linear line. Like y equals x, for example. But that's not the case. There's a horizontal asymptote. So we found that. Now we need to see if the graph intersects that horizontal asymptote. So if we come up here, our simplified version is y equals 3x plus 1 over x minus 2. So how do we figure out if y equals 3 intersects this graph at any point? We use substitution. If y equals 3 and y equals this, then we put in 3 here for y. So 3 equals 3x plus 1 over x minus 2. So let's cross multiply and see if there's a value of x that works. The 3 x's drop out, but negative 6 does not equal 1, which means the graph, or the function, which doesn't matter which one, does not intersect the horizontal asymptote. Alright, so we solved for that. Now it is time to graph it. So it's good to draw a X and Y axis if it's not provided to you on the test or homework problem, whatever it is. So in order to graph this, the first thing you should do is identify where the horizontal and vertical asymptotes are. So from part 1, actually right here, we figured out that the vertical asymptote is x equals 2. So for every line here, we're going to go up by 2. So if this is 2, then this is about x equals 2. And make sure you draw dotted lines because after all, the graph is going to be approaching this. But understand that a graph will, like I said, will never equal a vertical asymptote. Rather, it will never intersect. The next thing you need to do is draw the horizontal asymptote, which is y equals 3. So that would be about right here. And based on what these asymptotes are, you can almost kind of figure out what the graph's going to look like. So we can figure out whether the graph converges or diverges. Diverges when it goes like this, and converges when it goes like this. It would converge if the multiplicity of the denominator was even, but the multiplicity here is odd. It's just 1. So the graph will diverge in this case instead of converge. Now so let's write this to the side. The graph diverges. That's important to keep in mind. Now you're probably wondering, what points do I use? Well, in part 1 I mean, we solve for the x and y intercepts. -1/3 and 0, -1/2. So let's put that in. So this is about here, really close. And the y-intercept is right about here. So they're pretty close to each other. Now, before we draw the shape of the graph, before we draw it, we need to note that from part 1, we figured out that there is a removable discontinuity where x equals 3/2. So in other words, there's a hole there. And I said in part 1 that at the graphing stage, we would figure out the coordinate where there's a hole. So if x equals 3/2, we simply substitute 3/2 in here for x, and we need to solve for the y coordinates. So let's do this right here. So 3 times quantity 3/2 plus 1 over 3/2 minus 2. So this is 9/2 plus 2/2 over 3/2 minus 4/2. So this is 11/2 divided by -1/2. So this is 11/2 times 2 over -1. So that cancels out, so I'm left with -11. So there is a hole at 3/2, -11. So let's go to our graph right here, and 3/2 is, well, this is 2, so and this is 1, so about the middle here. Remember, each line's by 2. 2, 4, 6, 8, 10. Let's extend this line a bit. So right about here, and draw a white circle. That is our hole. And now that we've done that, we can draw a graph line where it shows it approaching this asymptote, and it shows it approaching this one. There you go. So that's a good graph, I would say, right there. Then here, because we understand it diverges, it's going to go something like this. Alright, so there you go. That is, I would say, a pretty good sketch of this function. So I hope part 2 has helped you, along with part 1. So we have finished this problem. And thanks a lot for tuning in. I hope you guys learned a lot.